talking
This
about,
conference will now be recorded.
I was talking about arrays, and we have completed that. Today, there is one more thing I would like to quickly finish, and then we were planning for collections. Even I am very much excited to get into the collections because that is one of my favorite topic in programming. But we didn't discuss what is the thing is. We didn't have. We didn't completely get into the string topic. We know what is string, right? So, but we have worked with string number of times, and we have used string in many cases. But only thing is, we didn't apply, the methods of string. There are so many methods inside string, and you need to get an idea about such methods. That is important. Excuse me. And we didn't apply those methods. Got it? But we know how to declare string and how to print it or how to use it. All that is fine. But one important thing here is string is also a class. We finished so many. We have done so much of object-oriented programming. This is a built-in class, and now we need to understand the methods of string, because sometimes when you are working on some kind of this data analysis. Suppose you read a text file and you need to split that text file. Okay, when you read text file, you get you read line by line, and every line is converted to a string. And on top of that string, again you apply some split function, and then you might do something else on that on that string. So because most of the time the data in the data sets, it might be JSON, it might be CSV, it might be DAT, or whatever it might be. Most of the time the data is comes in the form of a string. Might be, if required, we convert it to the numeric type. That is a different story. So when you are dealing with such string type of data, you need to get a clear idea about the methods of string, so that tomorrow when you are working on your Spark applications, this is going to help you a lot, dear friends. You got it right. So the question is, now there are simple things. What is a string? I don't need to tell you the definition, because we have already discussed. A string is group of letters or characters enclosed in double quotes. The easiest definition to remember is anything in double quotes in Scala. If you talk about Scala, anything in double quotes is a string, because sometimes some people get confused. Group of characters in double quotes means, if you don't give group, they might get confused. But anything in double quotes is a string. Okay, so you got it right, dear friends. Understood? So that is one thing. Look at this here. String is something which is in double quotes. Okay, the example is here. You can see here now. Another important thing. String is a class in Scala, even in Java, even in C#. Okay. So the point is, what it is a class. Even in Python, it is a class. And this is very much used data type, even in Spark. Okay. Now another important point is it is immutable. Immutable in sense, it's not like we cannot modify, or the point is, right? It's not like we cannot change the data. When I say it is immutable, I am not talking about val and var types here. If you declare something as val, it is immutable. Something as var, it is mutable. Means you can change that variable. That is what the purpose of val and var are. But when you talk about string, when I say string is immutable, we are talking about string object. I'm not talking about the variable initialization here. It's not about whether we can modify the variable or not. That's not, we are not discussing. Okay, one thing very important is it is immutable. What do you mean by immutable? I'll just explain with a small example. Suppose, let me open that Eclipse first of all. Meanwhile, I'll take a small example. So you take something like var space of S1 equal to something like Manohar. Now, when I say var here, you can reassign this variable. That is the meaning of var. If I say val, we cannot reassign it. That is okay. That is fine. Whether you reassign it or whether you don't reassign it, we are not talking about it. We are talking about string object. What is it? This object is immutable. What do you mean by that? Means we cannot modify this object. Once you create some object, we cannot modify that string object. Suppose you see here, I created a string object and as I do S1. Even now this is immutable. Now the string object is immutable here. Means what? It's not like I'm not talking about whether you can reassign or not. I'm talking about the object level change. Object level change. We will see with small example, and we will also do the analysis. Now you see, sir, I'm taking two strings here. I'm just taking one string, not even two strings. Where some S1 equal. I say something like Manohar. Then I say S1 equal to, now I say something like vidhatri. In the first case, I initialize string with what? Manohar. S1. In the second case, I modified it. In the second case, what did I do, sir? I modified this S1 now with vidhatri. Okay. So what's happening here? When I run this, if I said string is immutable, most of the learners are, most of the people answer this as they might think we might get an error. Okay, but we don't get any error here. If I run it this time, for first time you see Manohar, and you see that the second time the change happening in the string here S1. But still I say this string is immutable. Then you come up with a question. Sir, we are seeing a clear change here that S1 is modified with vidhatri. There is no more Manohar here. Still you are saying immutable, but where is notable? What is this? What is this discussion? What is the point here? What is the point of discussion? Then here we are not talking about assignment here. We are talking about object level change. Let's understand that with the analysis. Suppose take paint. Initially, you declared a string variable here, right? What is that? Var S1 equal to some number. Correct? Now, what happens? An object is created for the string in memory by your JVM. You know, right? When you run, JVM is going to do all this for you when you execute a program. Now, what JVM does, sir? JVM will create an object for this S1. This is right. It creates an object for this string, and this has some address 100. It is a string literal, of course. What is it? String literal, sir. I am directly initializing it. Okay. Now this Manohar is kept into this object. Now this 100 is assigned to this variable S1. This is a reference. Now S1 is referring to this object. Okay. So now this is what happens when you declare a string like this in Scala, even in Java. An object is created for the string, and that value is kept into that object, and that object has some address. That address is stored into the reference variable. Suppose this is immutable, right? It is not modified. And one more important point. Suppose I declare one more Manohar in the program. What is it? What I am doing now? I am declaring var space s2 equal to, again I am saying Manohar. So now what happens is, being immutable, the advantage is second time I declare the same string and I am printing s2. That is fine. There is nothing to worry. Okay. Now you know, sir, what happens here. When I run it, you get the output. We don't have any issues. Okay. But for the second time, your JVM doesn't create a new object for Manohar, for S2. Suppose I declared S2, right? What we might think, JVM creates one more new object from var space S2 equal to Manohar, means we expect one more object for Manohar. But actually JVM doesn't do that. As this is a string, as it is immutable, what happens is your JVM will see, is there any existing string with Manohar in the memory? Yes, that object is there. Then JVM doesn't create a new object. What JVM does, it will simply copy that address of existing object to S2 also. That's all. It does the same, sir. Now S2 is also pointing to this. What is that? Now S2 is also pointing to the same object, Manohar. Suppose I create one more object, S3 equal to Manohar, S4 equal to Manohar. Okay. In all these cases, if you are trying to declare Manohar again and again, means if the string is same, your JVM doesn't create any new object, but it will verify, is there any existing object with Manohar. Then it will simply copy the address of that Manohar to those references. Now all these references will be pointing to that single object Manohar. So this is now, when it has multiple references pointing to the same object, all of a sudden what I am doing here is so if not here, you see here now. Okay, after declaring S2, here I am modifying this vidhatri. I'm modifying Manohar. I reset it with vidhatri. Suppose if I reset with vidhatri, suppose if this vidhatri is modifying this whole object, that is, suppose assume that it doesn't happen. I'm just giving you an idea. Suppose this Manohar is replaced by vidhatri here. What happens? If the change is for S1, we don't have issue. But S2 has a problem, because whatever change you are doing, that should impact only S1 but not S2. Similarly, S3 and S4 might be there. Assume that. Just assume. Even they are also pointing to Manohar. Now, if you all of a sudden, because of one reference change, if it is modifying the whole object, all other references get impacted here. That's why what string will do now, what JVM will do, it doesn't allow this existing object to be modified. It doesn't allow this to be modified. You got it right, sir? This to be modified. Understood? What JVM do? Suppose, which one you are modifying here in the code? You are modifying S1. Then JVM will keep this object intact, doesn't modify this existing one. Whichever is modified, you are modifying S1. Then For that, another new object is created. For the modified one, a new object is created, and then that string is kept into that. A new address is initialized to this, and that is modified into this reference. That is updated in the reference. Now instead of 100, what is stored in S1 now? S1 is replaced with 100. Now, what happens here? S1 lost the link with this existing one. No, this got removed here. So this is removed. Now S1 starts pointing to which one? S1 starts pointing to this one. This is going to point to vidhatri. No, are you following, sir? Now what's happening here? Does this existing object is modified? No. Whenever you try to change a reference here, whenever you assign a new value to a reference, then a new object is created for that string, and an address is assigned to that, and the address of that new object is updated in that reference, which for whichever the variable you are making change, that change is applied only to that reference, not for all the other, not for existing object. This is called immutable here. Means, are we modifying existing object here? Are we modifying existing objects, sir? No. This is not allowed. Suppose you try to change some string variable, then a new object is created for that string, and then the address of that string is updated into that respective reference. And other references are still pointing to the existing object, so they don't have any impact here. And this is what immutability means with string here. The advantage of immutability is there is an advantage here, because as you have strings, you use a lot of strings in programming. This is actually a memory management technique, memory tuning technique. If you have same string for number of times, if it is coming for number of times, instead of creating multiple objects for every string, you are managing that with the one object itself, so that the memory utilization will become effective here. And that's what we call immutable is. You got it right, sir? So suppose if it is changing from object to object, what is that? If it is changing from object to object, then it is not that efficient. But here, if the string is same for many references, then in that case, this is efficiently utilized. Got the point, sir? Do you understand it? So this is the basic idea about immutability. Understood now? So to prove this, this point, like whether these two strings are same or not, S1 and S2, you can do one thing, sir. Either you can print that address, print of S1, S1 dot, you do one thing, sir. Print hash code. I told you, right? Again, print of S2 dot hash code. Before you modify it, I'm printing it in the beginning itself. Okay, now you run this, sir. Now if you see this, the addresses are same for S1 and S2. Just observe that. Can you observe it, sir? Address is same for, let me just print line by line. Now you see there, exactly same. That proves this point here. What is it? Both S1 and S2 are referring to this Manohar initially. When I modify, then S1 got changed to prove that point again. Suppose you print now after modifying here, you print S1 one more time. This time you see a new address for after change. Can you see that? It got modified here. Can you see it, sir? Understood now? But that change is applicable only for which one? Only for S1, not for S2. S2 is still pointing to the old object. Again, to prove that point. See this. S2 is still pointing to that old one. See here, still it is pointing to the old one. Got clarity here? Okay. There are some questions coming to me. So if no other reference for Manohar, then at that time, if you don't have any other reference, then okay, fine, that one object will be there. That's all right. Only one object exists. Even if you have same if you have Manohar for 10 times, even then you have 10 objects. Only thing is references are different, object will be same. No other reference. How can you have a string without any reference string, Suresh? At least one reference exists, right? You got it? Then it becomes anonymous object. If you don't have any reference, such objects are called as what, Suresh? We call them as anonymous objects. And anonymous objects are used for instant purpose. They are used for some instant purpose. They are created and they are destroyed immediately. Got it, right? That's the point here. Is it clear, Suresh?
Manohar, you mean whenever a string value is changed, the address is going to change, right?
Correct. That's what even we are seeing in the also, Bharat. Can you see here? We are clearly seeing that here. Suppose you change again one more, change S1 equal to something like Bharat. Okay, you see here now. Now you print S1 and S2. Now this time again the address will get modified here. You can see there a new address is created. Can you see there? First time
right
S1. Second time when I modified to vidhatri, address is this. Third time when I modified it to Bharat, address is this. Can you see that?
Yes. Here.
Is that clear now?
Yeah, Manohar, thank you so much.
Every time you try to change that string, a new object is created in memory. That is means what? The old object is not modified. The old object is still intact. That's what immutability here means. At object level, the string cannot be modified. At not at program level. Don't think at program level. I'm not talking about program level here. This is object level change, not at assignment level change. You got this point clear, all of you folks? Right. So this is the idea about the basic introduction, first thing. Now after that, you can create string in two ways, sir. Again, you can see, sir. One is you can declare as a literal. This is like this. Literal means like a constant, which you can directly initialize it. Second approach, what is it? You can create as an object. Like you can apply new, and then you can create that. If you directly initialize, sir, if you see here, if you directly initialize a variable like this, it's called string literal or string data or value, constant otherwise. And if you create through new like this new string, it is called string object. There are, however, here there are some differences. Again, let me explain this before we switch to the methods here. We have so many methods. We just quickly test all these methods. It doesn't take much time. So in how many ways we can declare string here? Two ways. What is the first way? Declaring it as a literal. And what is the second way? Declaring it as an object. Declare literal means directly initializing a value to a variable. Object means applying this new here, new space, that class name. Got it, right? Now, is there any difference here between these two? We need to understand. Suppose you see, let's apply same thing here. Suppose if I say new string of Manohar. Here also I say new string of Manohar. Okay, first let's see in this case. Let's observe till this point. Okay. Now in this case what happens? Let us just run this. Observe this once. What is the hash code of S1 here? S1 is same, and hash code of S2 it is also same. Clear now? Suppose in Java, if you create it as different objects, like when you create it as object, then there will be a different hash code for S1 and S2. But here, I don't see difference in Scala. I'm not seeing any difference in Scala because both objects are sharing the same address. So there is a slight difference from Java to Scala here. If it is Java, for S1 you get one object, and for S2 you get one address if it is declared as an object. But in Scala, it is not like that. If you create it, you declare as a literal or you declare as an object, it is trying to use the same address for all the types here. Got it right? Whether you declare as a literal type or object. I'm concluding this from the output, not from anything else. By seeing the output, the concept doesn't have any impact if you create as a literal or if you create an object. But in Java, this has an impact. If you create two strings as objects, even though the literal this value is same, but still the addresses will be different from S1 to S2. In Java, I can prove it if it is required. But in Scala, I am not seeing such thing here. If you see here, what is it? The practical proof is both are sharing the same address. Means in Scala, the conclusion is simple. You declare as a literal, you declare as an object. The concept of immutability will be the same. There is no difference for literal, and there is no difference for object type declarations. But in Java, there is that difference is there. The immutability changes from what is that? The concept of that changes to literal to objects. Is this clear now? So this is idea about what, sir? This is idea about two ways of declaring string in Scala. Hope this is clear for all of you. Now we need to understand methods of this string. Let's quickly apply all this. Let's try to finish it if possible today itself. Okay, now let's see this. Now you have seen even this method hash code. This can be applied on any object, not just only string here. So we need to talk about object what is that that class anything has to be discussed. We will do it sometime later. Now first let me test all the methods of string. First one. Suppose I want to find length of a string. Okay. Then it's so simple. These are all straightforward methods. You can simply say s1 dot. Then I'm also adding one more string set here for testing purpose. Var space s3 equal to. Okay. What does we take here? Rama is a good boy. Oh, this is S2 is already there. Okay. Or otherwise, I'll take my usual example. Bitty bought better butter. This let's have this. First one, I'm just length means it returns the length of string, like how many characters were there in that string, and that is returned here. Okay. Next one. Maybe if you want, you can quickly test it, sir. Just run it and add some string here. Just run it. length is 7. Okay, fine. Next, the next method, substring. So that's where we use third string here. In this, I just need only bitty here. Which one I need, sir? Just bitty. Bitty is a substring. This whole string has four, at least 4 words. In that, bitty becomes a substring, or bot becomes substring, bitter becomes substring, butter becomes substring. Even that space becomes substring in that string. So now, suppose I want butter. First case. Second case, I want bitty, or I want something in the middle, bot. So what shall we do for that? Butter means, right? First, you need to understand the index, right? These are all indexed data structures. Might be we have discussed about strings, right? String is, we have an idea about arrays now. 1D array, 2D array. What happens with 1D array, sir? Every array has indexing. Even string is also indexed data structure. A string is a one-dimensional character array internally. What is it, sir? One-dimensional character array. And by default, this index starts with 0 and ends with, I'm not sure what is the length here. Maybe, I know, right? The easiest way for me is, let me just say st.length. The length is 26 for that. Means it starts with 0, ends with 25, n minus 1. Okay. Now I want get butter. For that, we should apply this substring method. Which method I can apply? Substring. And there are two substrings here. One just directly returns the part of string that's starting at index I. Second one, if you want something at the beginning or at the middle, not at the last part, not at the end part, but somewhere in the middle or somewhere at the beginning, then you have to specify where it starts and where it ends. Suppose you want something from the middle to the last end of the string, then we can apply this, because just you need to pass that index where that string starts. From there onwards, the rest of the string is written by this type 1 substring. Type 2 means you can specify the exact substring, the positions, like where it starts and where it ends. That is type 2. Okay, we'll just see with quick example. If it starts with 25, means 24, 23, 22, 21, 20. So you see here, sir, I'm getting substring, applying type 1. S3 dot, you can simply say substring, and you can directly pass some 20. Okay, then this gives you what? Butter. From there onwards, let me quickly check. Let me remove this. Or we can also apply a comment for that. That's not a big problem. Okay, now substring of 20. This returns, can you see here? Substring is butter. Suppose I want something in that bitty here. What is the starting index of bitty? 0. And what is the end index of y here? What is the index of y? 1, 2, 3, some 4. Okay. Then here, suppose if it is not at the end, if the substring is not at the end of string, but it is at the beginning or in the middle, then you have to specify the start index and end index of that string. Okay, is that clear for all of you? So what should I do right now, sir? If I want bitty in this substring, I have to mention the start index, start position, and end position. Then I get bitty. Can you hear now? Okay, still we have to pass 5. that 5 is excluded, sir. Here end index is excluded. You will take up to only 4. That's why I got only bit. I didn't get y. Now I get y also. And in the second case, what happens, sir? This end index is excluded. That last, when it says some start index is 0 and the end index is 5, it will take up to 4. Got it right? That 5 is exclusive, not inclusive. Got it right? Upper limit is excluded. This is the idea about substring. These are straightforward methods, sir. Got it? Next one. There is something, one more thing, slice. This is very much popular in slice concept is very much popular in which one, sir? In Python. They use some index operator for that. Okay, let me just quickly try this slice. So here, instead of substring, I apply what? Slice. Now run this. I am seeing some. Okay, let me run it and see. You got 50 here. Okay. Maybe you can apply slice in different ways. So I hope when I say 0, we have to declare both start index and end index. Fine. This is another way of getting substrings. Applying slice. This also returns as substring. Okay. Next one after that. Contains. Contains means, suppose if you want to see that if your string has any character or any substring, if you want to check for any substring or character in that, then this contains is very helpful for us. And it returns a boolean. Suppose if that substring is present or if that character is present, then what happens here is this returns that boolean value. If it is not present, it returns false. If it is present, it returns true. Contains is a direct, straightforward, right, sir? If you have something in that or not. So suppose here I'm just checking for S3 dot. These are all straightforward, sir. Contains of. I'm just checking for BT. If BT is there, then what happens? BT is there. Then this contains returns true, sir. Can you see that? Suppose instead of BT, okay, instead of BT, I put it as a booty. Okay, now is booty there or butty? Is butty there? We don't have that. So you get false here. Can you see that? That's what contains does here. The next one. Index of. Suppose I want to know the index of some substring or some character of in a string. Okay, right? String is indexed data structure, and the index starts from 0 to n-1. And if that is the case, what is the point here, sir? How do I get the index of a string or a character of a string or substring of a string? The easiest way is applying index of method, and we can use it in two ways. You can see we have overloaded methods here again. This is the advantage of overloading. Now you can understand the real purpose of overloading. Type 1, which has only one parameter. Suppose you just specify a substring, it gives only one occurrence of that substring or a character. Suppose you want to see that, suppose bit is repeated for 3-4 times. Now I want to see the other occurrence, okay, other than the first occurrence. Then the second type can be used. We'll see that quickly. We can just apply here. Suppose you see here, sir, these are all simple and straightforward again. Index of, suppose you say You can directly take it, sir. Index of BT. Now what happens, sir? You get the first occurrence and the index of BT. It gives the starting index of BT, sir, not the whole string here. The string starts with some index again, and that will be given here. That's all. Okay. And then the other one. Suppose I have a BT one more time. Now I want the next occurrence of BT, not the first occurrence. Suppose by default, when I apply index of BT, it gives the first occurrence. Suppose I want the second occurrence or third occurrence, where third occurrence is coming, where fourth occurrence is coming. Then in that case, I have to mention that string and also from where I have to search. Already first one is there from 0 to 5. Now you give the position from 6. Means what? It will search for this BT after 6th index onwards, not before 6th. After 6th, it is going to search for that bit. Default, it will search for first occurrence. Now you see, sir, you see here. I'm sorry. Here I have to apply index of non-contains. Now runs. Okay. Index of, okay, this one should, because it is not there, right? Booty is not there. One more important point. If that string exists when you are passing to index of, if that string is there, you can see for BT, for first occurrence, it gave you 0. But booty is not there. Suppose whichever you are passing here to index of, if that string doesn't exist, then what happens here, sir? It returns -1. Can you see it? Now let me correct it. You will get right thing only. Now nothing to worry about. You can see there it's giving me 27. Perfectly, the starting index of second bit is 27. Got it right? This is idea about what? Index of. Next one. To lowercase, capitalize, reverse, is empty, non-empty, ends with, starts with. These are all very straightforward functions. To lowercase to uppercase. So there is nothing difficult here, sir. When you apply to lower uppercase, it converts a string to what? Uppercase, sir. When you say S3 dot to lowercase, I don't think you need to pass string here. Can you see that? This whole string is converted to lowercase. Already it's in lowercase, but let me just see. Even that B is converted to lowercase here. Earlier B is in uppercase. In BT, B is uppercase, but now it is even converted to lowercase. Suppose I want to convert this whole string to uppercase. This converts the whole string to uppercase. Okay, you need to change this. Probably this is for contains. And this is also for contains. This is for index of. This is also for index of. This is for lowercase. This is for uppercase. Okay. Capitalize means you can see here, sir. When you apply capitalizer, it will just add capital letter to the starting word, to the starting letter of a word. That's what capitalize will do here. We will test here quickly. Suppose you can see here capitalize. Here I say something like Manohar dot instead of that bitty thing, capitalize. Okay, you can also try like this. Why error? 1 minute. Unspecified. Okay, let me run this now. Now you can see that. Don't apply parentheses for that. Okay, that's all. That's the problem there. It doesn't have a parenthesis. That's why it's throwing an error. Now the starting letter of Manohar is converted to uppercase here, capitalized. Next one. The reverse, just reverse the string, sir, nothing more than that. So here, reverse of, if I say something like, you can directly apply BT here. You can directly apply these methods on a string also, sir, not on a variable. You can also apply like this. Now run this. BT gets reversed. Can you see that? Next one. Empty means it will say whether string is initialized with some value or not. Suppose string is set to null, it returns what is it? True or false, sir. Is empty returns true or false. Okay. They were saying something here. S dot length equal to 0, S dot length not equal to 0. Non-empty means which is not empty. Now, definitely these strings are not empty here. S1, S2, S3 are not empty. Here when I say is empty, then you can just see S3 dot is empty. It returns false, sir. So again, S3 dot is empty is non-empty. It returns true because it's non-empty. It's not empty. S3 dot non-empty. And here we are trying for non-empty like this. You can see, sir, all these methods, how these are useful for us. It starts with, ends with. Suppose you want to just check whether a string starts with some kind of a substring, like, I want to just see whether this string starts with BT. Here, these are all straightforward methods, sir. Starts with, you can say S3 dot starts with, pass a parameter here. What is it? Something like suppose 50. And we can also check for ends with. Means it returns Boolean, sir. This is empty, non-empty, starts with, ends with. What all this does here is, it's simple, sir. They just return some Boolean. If it is doing it, it returns true. If it is satisfying the condition, otherwise it returns false. Okay. Suppose ends with BT. It sees that whether that string is ending with BT here. Both are true, sir. We don't have an issue. Perfect. Can you see that? These are all very simple methods, sir. Next after that. Replace. Replaces, what is it? Old character with new character. That is one thing. And also there is type 2. These are overloaded again. See there. You understand the advantage of overloading. Same method, we can use it in different ways by passing different parameters. So this is second type should be for strings. First type is for character. We will check it and try it, sir. We'll just apply it. We are almost at the end of closing all these things. And in this split is very important method. Okay, and format is fine. More than format, split is very useful for you because even in Spark we apply the split lot of times. Got it right, sir? So let me just copy and paste it. What is next one here? replace. Suppose in the bit replace is something like this. I have bit and here I am just applying S3 dot replace. Okay, I'm just checking on S3. Replace capital B with small b. Let's just run this. Let's just run this. I want capital B to be replaced with small b here. It's happening here. Can you see that? Now again replace. I want, instead of replacing character, I want to replace a string itself. Now bit t should be replaced with the butty. Okay, new string, old string, new character, old character. Sorry, old character, new character, old string, new string. That's all. Let's run this. Now you can see bitty got replaced with the butty. Got it right? Next one. So this is the idea about all this. We are almost at the end of finishing these things. And trim. The purpose of trim is to remove the spaces, trailing and leading spaces. Spaces at the beginning and the spaces at the ends. Got it right? So how do you do that? You can apply this trim function. Suppose you have a string like this. Just we'll directly apply it, sir. We don't need to waste time. Trim means like your trimmer, sir. What trimmer will do? Something, it removes unnecessary extra beard or something, right? Like that. So you take a string, okay, something like Manohar. I'm taking space in the beginning and at the ending. Dot, I said trim. What happens here is it will trim this starting space and ending space. Something, if suppose if space in the middle, Manohar is a teacher. When I say this, okay, it doesn't trim the middle spaces. Sometimes learners ask this question. The purpose of trim is not to trim the spaces in the middle, but to trim the spaces at the beginning and ending of a string. Following, sir? Okay, now run this. See there. Okay, you don't see it whether it is trimmed or not, because we're not sure about that, right? Suppose I don't use space here. See here now. If I don't apply string, you can see even I put space at the beginning of this Manohar is a teacher. Now when I apply this, now you can see that there is no space between Manohar and is. To get more clarity, before applying trim, after applying trim, let us see this. Now you can see is and Manohar has space, because even though we don't have space at trim is, at the beginning of Manohar there is a space, so we can see space here. Now on top of that, apply trim here. Okay, now run this. Now you can see there is no space between is and Manohar. Why? Because trim has removed the spaces at the beginning and ending of that string here. It trimmed that spaces. That's clear. Okay, sir. Now split. A format we'll discuss at the end. Split, another interesting function. Now you know, right? What split does is it will split the string by a delimiter. Suppose you know, right? In that S3, you know, it's a very big string. It has it's a line of string there. Such strings we need to split sometimes, and we need to split by some special characters, either by space or either by comma, either by some special symbols like hash or dollar. Okay, we need to split based on some special characters, sir. So the question is, if I should do that, then I have to apply what? Split function. Now you can see, sir, where some str equal to, I'm just using a variable. I'm assigning to a variable to show you, what happens when we apply split. Split of, pass some space here, and now I'm applying split on this S3, sir. If you see here, I'm applying on S3 and the delimiter. Delimiter means by what these words are separated, and it should have a common delimiter throughout that string. For at the beginning we have space, and after that comma, after that hash. That doesn't work. You can use either any one delimiter, and usually in real time, either it might be space or comma, or hash and dollars are very rare. Okay, or you have fixed length strings. Now here I am applying space here. Now when we print this string, what happens now? Let me just print now for str. Let's see what happens. Run this. Now you can see here it got some array here. So what is that I got when I apply string? When I apply this split on this, this is an array. Now what should I do is first of all I should iterate it. Let me just apply an iteration for I on str. Right, how to apply iterator. Then I should iterate this, print this I here. 1 minute. Let me print this I. Okay, run this. Now you can see there, right? So when you apply a split on some string with some words in that, then it will split all that words and convert it to an array. And you put a cursor here. Let us see what is in this string here. You can see their array and array of strings. You can see there. Why array of string? Because that array has all list of strings there. What split will do? The return type of split is array. Can you see there? That function split returns array here. Can you see there? Now what it does? It will split that whole string and convert it into words, and those words are stored into this array. And you should iterate it to see each value in that array. Got it right, sir? So this is the idea for today. Okay, I think we have almost all covered every method that is available in string class. Following, sir? Got some clarity here about string classes now? String class, string method, immutability of string. Is that clear for everyone, sir? Understood. So you need to test it, sir. If you wish, you have time, you can test it. Otherwise, we can do it tomorrow, sir. Anyhow, tomorrow we will test it once in the beginning. Okay. And then I will make you to work on a couple of use cases, like on split and removing duplicates thing or something like that, and checking the occurrences. We'll do some logics, couple of logics. Let's have some brainstorming tomorrow for some time. Then we will switch to the collections. I am also excited, sir. Don't think I am postponing. Even I am very much interested to start collections. I am sure even you are also eagerly waiting for that topic. Okay, that is one of the most core concept of this big data. Collections are very much useful for us. Okay, let me add this code here. We prepared all in one example, so let me just put it here itself. Okay, tomorrow we will test it, and we will finish it, sir, and then switch to the collections. Clear, sir? All of you are good?
Manohar, one quick question, last one.
Yes, but please.
We have declared a variable has an object, right? Variable a colon string equal to abc, and
Okay.
where b equal to new string of double quotes abc. What is the difference?
Okay.
Is there any difference?
Probably the where might be the storage area might differ here, Bharat.
Bharat.
No, right?
Okay.
Usually
Okay.
literals are stored in string constant pool.
Okay.
When you say new, when you say new on something, you know,
Mhm.
when you create it as an object, these are stored in a memory area called heap.
Okay.
So that is one difference. And also other difference might be that it comes with garbage collection, if I'm not wrong.
Okay. Okay.
There might be some impact on garbage collection. Usually not garbage collected until you completely close this thing application.
Okay.
Okay. But the objects in heap are eligible for garbage collection once it loses reference to that object.
Got it.
You got it right?
Yes. Yes.
So likewise, no, there are definitely there will be some differences. Probably that will be more related to the memory related to. Got it?
Got it, Manohar. Thank you.
One more thing is objects generally takes more memory than declaring it as a literal. That is for sure.
Oh. Okay. Okay.
Got it right?
Hmm.
So that is the difference. I will also see if any more differences were there. Okay.
Okay. Thank you.
Any questions, folks? All of you are good now? Any more questions, please? No questions? Then we will stop it here. Then tomorrow we will catch up, sir. All of you. Then we will finish up collections maybe within next 1 or 2 weeks, and then switch to the Spark. Okay. Probably Spark, if possible, we will plan on the weekend itself. I will update it probably by this Thursday or Friday. So whether to have sessions on weekends or not. So if we are finishing these collections here quickly in our regular sessions, then we will continue like this. That will be more, no, this thing. It will be more what do you call disciplined than weekends. We'll see that. Thank you, sir.